Hello kids, welcome to the science class. In the last video, as I said, that the next video will be about oxidation reduction reaction and corrosion and density. Before we proceed, I hope that you must have seen the previous video. Okay, and if you have not seen, then I have given you all the links of this chapter in the description box, so you can revise the entire chapter by looking at those videos. Okay, so now let us see oxidation and reduction reaction. By the time you can keep your textbook open to page number 12. Okay, the first activity which is given in your textbook, that is you have to take copper powder in china dish and you have to apply heat. It is not given that you have to apply heat, but in the figure itself you can make out that when you take that copper powder in china dish, you have to apply external heat. So what will happen? The copper powder will react with air. And what is present in the air? Oxygen. Yes, correct. So copper powder will react with oxygen and we will be getting the black color substance, that is copper oxide. You can see the first equation I have written here, that this copper powder is taken in china dish and on heating it will react with oxygen present in the surrounding, and then this oxygen will combine with copper and we will get black color copper oxide. Right? You can note it down in your textbook. Now let us recall the activity 1.1 which we did. Right? Where we had taken magnesium ribbon and we have applied heat, and this magnesium will combine with oxygen and it will start burning with a dazzling flame. Dazzling flame means जब हम दिवाली में पटाखा जलाते हैं, right? So those sparkles, they burn with the dazzling flame. So same type of dazzling flame we will be able to notice, and at the end of reaction we will be getting white ashes of magnesium oxide. So in this reaction also, this magnesium and oxygen, they are combining with each other, or I can say this oxygen is getting added with magnesium and here we are getting magnesium oxide. Right? So this is also a type of oxidation reaction. Right? Now here you can see I have written both. This about specifically this reaction, that it is oxidation as well as combination reaction. So here why is it so? Because magnesium and oxygen, they are combining with each other to form a new compound. Please recall the definition of combination reaction. So here in both these cases they are oxidation as well as the combination reaction. Right? So what is the definition of oxidation? It is the process in which the oxygen is added. Please remember this. In oxidation, what is added? Oxygen. OO. Right? And what is being removed? Hydrogen. You just remember only one thing, that in oxidation, oxygen is added. Fine. And hydrogen is removed. That is completely opposite. Fine. The last thing, that is in oxidation process, the electrons are also lost. Here you can see that I have written oil, that is oxidation is loss of electrons. So this will help you to remember that in oxidation what is happening. Right? Let us recall the definition. What happens? It is the process in which the oxygen is added, hydrogen is removed and electrons are lost. Right? Exactly opposite to that, reduction is there. But before proceeding towards reduction, let us see the example where the hydrogen is removed. Right? From this alcohol, methyl alcohol, hydrogen is removed. Right? And in the last one, where sodium metal, it is getting converted to sodium ion with the release of, or with the loss of one electron. Right? Even in case of zinc metal, we know the what do you say, the electronic configuration, or I can say the valency. Right? Last year we had learnt about valency in 4th chapter in structure of atom. Right? So where we have discussed about all the metals and its valency. Right? So here sodium metal is getting converted to sodium ion with the release of one electron, or with the loss of one electron. Same way aluminum, it will donate 3 electrons and it will form Al3 plus ion. Right? Now let us move to reduction reaction. It is completely opposite to that of oxidation. where what is added? Hydrogen is added. What is removed here? Hydrogen is removed. See, exactly opposite I said now. Now here what will be removed? Oxygen will be removed and the electrons will be gained. Right? Here you can see the example where the hydrogen is added. Right? Now about this we will be learning in further lesson about saturated and unsaturated hydrocarbon. That time you will be able to understand that why this is happening. Am I clear with this? Now here removal of oxygen, you can see copper oxide when reacts with carbon, copper will be released, or I can say copper will be separated, and this oxygen will get combined with carbon and it will get evaporated in the form of carbon dioxide. Understood? The last, gain of electrons. Fluorine, right? When it gains 2 electrons, it will get converted into fluoride ion. Or I can say here we have taken the examples of metals and this is a non-metal. Am I clear with this? So this is all about oxidation and reduction reaction. You can have a look in your textbook also. Now let us see what do you mean by redox reaction. Redox reaction. If you can notice on the board what I have done. Check the spelling. Red and ox. Red stands for reduction and ox stands for oxidation. Means the reaction in which both these reactions, that is reduction as well as oxidation, are taking place all together. Those types of reactions are considered as redox reaction. Please note down the definition in your book that the reactions in which both reduction and oxidation reactions are taken place together, that is known as redox reaction. Okay. Now here I have tried to give you the example that when copper oxide reacts with hydrogen, on heating, this oxygen will get combined with hydrogen gas to form water. I'll repeat, in the reaction when copper oxide reacts with hydrogen gas, on heating, this oxygen present in copper oxide will get combined with hydrogen gas to form water. So here from copper oxide what is removed? Oxygen is removed and given to hydrogen. Now removal of oxygen is what? What is removal of oxygen? It is reduction, right? If you can see this removal, you can see this from copper oxide, oxygen is removed. So this reaction is known as reduction, right? Now oxygen is getting added to hydrogen gas, right? So here addition of oxygen is taken place, right? So this reaction of this is known as oxidation. So here you can see that reduction is also happening and oxidation is happening. So this type of reaction is known as redox reaction, right? Now one thing you have to remember that the molecule or the element which undergoes oxidation. Now what is getting oxidized here? Hydrogen gas, right? So it is called reducing agent. This is opposite. This is very important and it is a little bit confusing also. I'll repeat, the molecule or the compound or the element which undergoes oxidation is known as reducing agent, and the molecule, compound or element which undergoes reduction is known as oxidizing agent. So here oxygen is removed. So this copper oxide is acting as the oxidizing agent. Here oxygen is getting added to hydrogen. That is, hydrogen is oxidized. That is why it is known as reducing agent. I know you will or you may find it difficult, but it is very important for you people to understand the meaning of reducing agent and oxidizing agent. Or one thing you can do, that the name, if it is reducing agent, means this particular agent is undergoing oxidation. Exactly opposite, right? For oxidizing agent, it is undergoing reduction. Understood? So this way or some other way, you can find your own easy way to understand the definition of both these types of agents. Hope this is clear. What is the meaning of redox reaction and the example. Fine. So in these 4 examples of reactions which I have given you, of course they are redox reaction only. What you all are supposed to do, you have to note down the way I have done here for this example, right? I'll brief you the first one, or let it be, it is just like this. Let us move to this one. Fine. Now here water when reacts with magnesium, it will give us magnesium oxide with the release of hydrogen. Now let us start with this. Oxygen. Where is this oxygen? It is getting combined with magnesium oxide. So here oxygen will be removed from this to form hydrogen gas. So this reaction from H2O to H2, that is going to be removal of oxygen means reduction. Very good. Now here with magnesium oxygen will get combined. So from magnesium oxygen is added. So which type of reaction it is? Oxidation. Very good. Right. Now here magnesium is oxidized. So it is acting as the reducing agent. And here water is being reduced. So it is going to be oxidizing agent. Am I clear with this? If you do not understand, you can refer to this once again. And then first note down oxygen. Where is this oxygen going? Fine. What about this copper oxide? From copper oxide oxygen is removed. So from copper oxide to copper oxygen is removed. So which type of reaction is this? Removal of oxygen is? Very good. It is reduction. Now here from magnesium oxide oxygen is added. So this is going to be your oxidation reaction. Am I clear? So this way just note down whether oxygen is removed. If it is removed, it is reducing. If it is added, it is going to be oxidation. Am I clear? So this way you have to sort out all these 4 redox reaction like the way I have done. Fine. So let us start with the last topic of the chapter, that is corrosion and rancidity. Right? Both these reactions we have already faced, or I can say experienced in our day-to-day life also. Right? So the definition of corrosion is, it is the process of slow destruction of metals and manufactured materials which are having metals. Right? So it is only related to metals. Fine. When these metals, they come in contact with the environment. It can be the air, it can be water, it can be acid. Right? So when these metals or the manufactured materials with metals, they come in contact with air or environment, or I can say water and acid. Right? So whatever reaction happens, that process is known as corrosion. Right? These are the best examples of our day-to-day life, that is rusting of iron, black coating on silver as well as green coating on copper. Right? Just have a look at the objects which I am going to show you right now. See this. All these things are available at our home only. Right? This is the scissor. These 3 things are used in puja. Right? This and this, they are made up of copper. You can see green color coating is there. Right? This diya, that is made up of silver. You can see the color has been changed. And here in this case of this scissor, that is made up of iron, you can see the color has been changed. Right? So this change in the color, or I can say the appearance of the object has been changed. This is nothing but it is corrosion. Okay. Now let us see how to prevent this corrosion. So the first is oiling the metal surfaces. Right. Next is painting the metal surfaces, powder coating the surface, electroplating and galvanization. What is galvanization? It is nothing but the protective layer of zinc is being applied on iron or steel surfaces. Am I clear? Now let us move to rancidity. This is also experienced in our day-to-day life, right? Where the oxidative deterioration. Deterioration means something is getting destructed. Okay? Deterioration of what? The oils and fats which are present in the food items that we eat. Right? So this oxidative deterioration will lead to the change in the odor and taste of the particular food item. Okay? You must have noticed that if you have brought chips from the market, or if any fried items are kept as it is at the room temperature for 1 month or so, right? The taste of that particular food item has already changed. Why? Because it undergoes oxidative deterioration. Am I clear with this? Right? So prevention to this rancidity is by using antioxidants, vacuum packaging, refrigeration, using airtight containers, storing the food items in the dark place, and using nitrogen gas for packaging. Okay, so here in case of rancidity also you have to learn the definition as well as its prevention, or I can say preventive measures. Am I clear? So hopefully you have understood the meaning of corrosion and rancidity very well. Fine. Now few questions are given in your textbook on page number 13. Please open to that page. The first question is, why does the color of copper sulfate, that is CuSO4 solution, change when the iron nail is dipped in it? That is, which reaction it is talking about? Yes, exactly. It is talking about the displacement reaction. Right? Now here the color will be changed because iron is more reactive than copper. Please recall the reactivity series which we did in the last session. Right? So the answer to this question will be because the iron, that is Fe, is more reactive than copper, it will displace copper from copper sulfate solution and will form green color iron sulfate. Am I clear with this? The next question, give an example of a double displacement reaction other than the one given in activity 1.10. This you will be able to write on your own because we have already given enough examples for the same. Fine. Identify the substances which are oxidized and the substances which are reduced in the following reactions. Right. This also you will be able to solve because more 4 examples I have already given you to solve the same. Am I clear with this? So hopefully entire chapter is very well understood by y'all, and if you have any query or anything regarding any of the concept, you can drop the comment in the following comment box. Right? So stay tuned for the next video. Thank you.